Hi everyone, this is Spandana and I'm here to talk about my final project, which is on myocardial infarction complications dataset. This dataset can be found in UCI machine learning, and it has 124 variables and 1700 instances. So myocardial infarction is a leading problem in healthcare, and it is mostly known for its unknown, unexplained, and varied number of complications. And this data set sort of helps us to understand some of these complications or why these complications are happening. And coming to the data part, it has, as I mentioned, 124 variables and 1700 observations. Of these, 13 are target variables and 23 are ordinal, which has more than two levels, and 9 are numeric variables and rest all are booleans. So the data consists of information related to the patient's hospitalization, their pre-existing conditions. There is also the numeric features are mostly the age and their test results, and the others are types of treatment they received during their hospitalization. These are all the packages that I've used. Apart from that, coming to the data acquisition, the data didn't have any headers, so I had to impute them. And this Most of the data, as I mentioned, they're categorical and ordinal. But when the data is acquired, they're all in character form. So I've just manually selected the numeric columns and converted them to numeric, and the rest I've converted them to the factors. Just checking the distribution and the conversions if they have applied or not. As you can see, everything is character before, and yeah, after conversions, they're all numerics, and there are also a lot of NAs in the columns. So, of the 124 variables, the first one is record ID, which I've removed, and there are 13 target variables in the data. I didn't want to deal with other 12 because the one I have selected already has few of those variables. So I'm just going forward and removing those 12 target variables from the data set. So coming to the NAs, there are a lot of NAs. There are NAs in almost all the columns of the data. So there are a lot of NAs, and due to the class imbalance, I have removed any classes which have more than 30% of NAs. And apart from that, the numeric columns also have NAs, which I have imputed using median, and the categorical columns which are more than two levels, those ones I have imputed with the mode. And apart from that, the rest of the Boolean columns which had NAs, I just remove them because I really didn't want to deal with imputation of booleans. And I did have outliers in my data, but these are not the values which are very outlier type. They are very much possible in clinical settings. So I'm not. I've decided not to remove them, and I will go ahead with the outliers. Apart from NAs and outliers, the data also had columns which were completely with single type of rows or levels. As you can see, these are all the distributions of the booleans, and idea of the distribution at a glance. As you can see, there are 1 4, and before removing the ones which had only such distribution, this was how the class imbalance was. 1150 zeros and zero ones. So I removed them, and then coming to the lethal component, it actually has 8 levels, but I because one of the level was 84% and all the other seven contributed to only 16%. I just converted them to zeros and ones. So right now they have, as you can see, 984 of zeros, and the rest are all converted into one. And Coming to the numeric features, I have for the sake of correlation, I put them in a separate data set, and this is what the correlation is between the numeric features and the target variable. I've standardized the numeric features and also applied transformations. So these are the histograms, and apart from age and serum sodium levels, everything else didn't pass the normality test. So I have applied square root transformations. Of course, I've checked in all of them, but I felt that square root transformations were better. So coming next, since there is a class imbalance in target variable, I've upsampled the target variable using upsample function, and now I have a class distribution of 984 for each 0 and 1. Since all of the columns are booleans and mostly the other are numerical, the rest of the columns which had more than two levels, I've converted them. Uh, I've one hot encoded them, and after one hot encoding, I am left with 179 variables, and I'm going to run my PCA analysis on the data set which has 1968 observations and 179 variables. So removing the target variable from the analysis. So the PCA, this is the scree plot it gives. So as you can see, the top 10 dimensions of principal components, they only attribute to around 25% of variance. So and as per eigenvalues and other the proportion of variance, around 100 variables explain 90% of variance. So I was fine with the 85% of variables, which amounted to around 91 variables. So in those 91 columns, there were also columns which included the one hot encoded path. So I've decided in the end that I would keep the 94 variables. Coming next, even after removing almost 70 to 80 columns, I'm still left with 99 columns. So I have run one more feature selection procedure, which is like a recursive feature elimination using um, random forest. I already ran the model, so I'll just show you the results of the RFE analysis. So it gives me an with the features of, as I've inputted only 10, 25, 40, and 50. It gives me with these accuracies, which has, and the highest one would be with the 50 variables. And the accuracy, as you can see here, model with the 50 variables was significant, and hence I selected that. And right now, in the final model which I've selected for my analysis has 53 variables and 1968 observations. So I'm splitting the data as per 70-30 split. And the algorithms I chose are random forest, naive Bayes, and KNN algorithms. So random forest gives me the best accuracy so far. I've applied it on all three, seeing that I have mixed type of data and everything is numerical for now, and there's a classification problem. So I think those three work the best for the classification. And since I have applied k-fold cross validation using the train control in Carrot package, this gives me different results. The This is a plot of the accuracies, and these are the models with different tuning parameters. The M try one with 227 and 52, and I think the best one is with M try 27. Same with the naive Bayes. It gives me a bit lesser accuracy, about 75%, but I think that works well, and the same with the KNN. KNN performed well as well. So the best K value was apparently 5, and the accuracy is almost 80%. So, using all these three algorithms, I've made an heterogeneous ensemble model and used the majority voting since this is a classification problem. So, I preferred majority voting, and so heterogeneous model performs poorly than the other than random forest to be accurate. The accuracy of random forest was 94% and heterogeneous ensemble was only giving 93. And even in terms of precision and recall values, random forest, homogeneous random forest ensemble model were better. And the AUC plot, this is the AUC plot. Which again confirms with what we have seen in the table above. The accuracy or the AUC of random forest is way better than the other models. And trying it on new data set, which are randomly selected from the sample since it needed the same level of factors to work. So, and all the three homogeneous models predict the same. Sorry, I think naive Bayes predicts 0 since the accuracy is less that can be expected. The other two, yeah, they predict the one and one levels, which is some sort of complication seen as per the given data.